Today I'm going to explain about basic tie-set matrix and branch currents, basic cut-set matrix and branch voltages. So this topic is from module 2. So first is about basic tie-set matrix and branch currents. So using basic tie-set matrix, how to find the branch currents. So this is written, that means branch currents are found using this tie-set matrix B and also link currents. If IB is a branch current matrix and IL is a loop current matrix, IB is a branch current matrix, I suffix B, and IL is a loop current matrix. Then B is a tie-set matrix, already known. Tie-set matrix is denoted with the letter B. Then the branch currents are given by IB is equal to B transpose into IL. That means transpose of the tie-set matrix multiplied with the link currents. Okay, loop currents. So loop currents means link current matrix. So here just telling BT is nothing but transpose of the matrix B, and IB and IL are column matrices. IB and IL are column matrices. So to find the branch currents using tie-set matrix, we need to remember this relation. Branch currents are given by transpose of the tie-set matrix multiplied with the link currents. Then we are able to calculate the branch currents. Then cut-set matrix. Okay, basic cut-set matrix and branch voltages. So here it is possible to find this branch voltages. That telling that it is possible to find the branch voltages as a linear combination of tree branch voltages and cut-set matrix C. Using cut-set matrix and tree branch voltages, we can find the branch voltages. So here notation, see that if VB and VT, VB, V suffix B and V suffix T, VB and VT represent the branch voltage matrix and tree branch voltage matrices. Okay, branch voltage matrix and tree branch voltage matrix respectively, and C is the cut-set matrix. Then then the branch voltages is given by C transpose into VT. C transpose multiplied with the VT. Okay. So here VB is nothing but VB we know that branch voltage matrix. VT is a tree branch voltage matrix and they are column matrices. And C is a cut-set matrix, and CT means transpose. It's transpose. Okay, transpose of the matrix C. So to find the branch voltages using cut-set matrix, okay, this is a relation. Okay, so this is the equation need to remember. Okay. So let's look at the problem. How to find this branch voltages as well as branch currents. Okay. So first problem is, okay, given like this, taken like this. Determine the branch voltages using cut-set matrix. Determine the branch voltages using cut-set matrix. Okay. So graph is given. Okay, graph is given. So in the problem, so this is a problem given. Okay, so here if you can see the nodes. Okay, there are 4 nodes. You can see A, B, C, D, and the branches are how many? 1, 2, 3, 4, 5, 6. 6 branches. So here know that nodes are given notation using English alphabetical letters. In my previous lecture, I have explained nodes taken with numbers, okay, and branches with alphabetical letters. So at that time I mentioned, okay, the notations may vary. Okay, sometimes they take nodes, they represent nodes with alphabetical letters and branches with the numbers. So here in the problem they have given the graph nodes represented with the alphabetical letters A, B, C, D, 4. Okay, 4 number of nodes. And branches are represented with the numbers. Okay, 1 to 6. Now, first we need to, according to the question, first we have to find the cut set matrix for the given graph, and then we have to write down the branch voltages. So this is what I have taken. I mean, first I have considered the tree. I have taken the tree. Okay. Then I have seen the number of cut sets I can get, possible number of cut sets. So from that I have written cut set matrix. So we know that is how, from my previous lecture, that is how a cut set matrix is obtained. That is obtained based on the, okay, its order is given by number of cut sets and number of branches. So you need to take a graph, okay, first thing, then accordingly get the possible number of cut sets. Okay, based on that we can, using that we can write down the cut set matrix. So here, look here. So consider the following directed graph, okay, with the selected tree. Okay, selected tree. Okay, so tree I have here, that is shown with the solid lines, the branches of the tree. Okay, as I already mentioned this previous lecture also. Okay, so here the tree I have shown with the branches 1, 3, 4. Okay, so we know that what is meant by a tree, right? A tree is nothing but a connected subgraph of the given graph, but without no closed path, without loop, but the number of nodes are same as the given graph. Okay, so here the tree is taken with the branches 1, 3, 4. Okay, that means no closed path. Okay, and nodes are same, 4, A, B, C, D, and the remaining branches form the core tree, which is shown with the dotted lines here. Okay, so the branches, its related branches are 2, 5, 6. Now, so I'm showing the next step, possible number of cut sets. Okay, so here we know that basically what is meant by a cut set. It is nothing but a minimal number of branches, okay, which consists of one and only one branch of the tree together with the links. It consists of only one branch of the tree together with the links. So here one possible cut set I have at this node, okay, node A, where see that cut set 1. Let us denote that with C1. So here if I draw the C1 here, cut set like this, okay. So if you can see that it consists of only one branch here, that is 1, okay, this one, and the remaining branches are the remaining are the branches of they are the links. Okay, so that's why this is one cut set here. Okay, and also know that cut set means always we can draw at a node. Okay, cut set we draw at a node only, which consists of only one branch of the tree together with the links. Okay, so this is one cut set we can draw, C1. Then cut set 2 I have shown at the node B. So node B, here if you draw the cut set here, denoted that with C2, it consists of the one branch of the tree, only one branch of the tree, that is 4. So then the remaining branches are the links. Okay, this 2 and 6, 6 and 2. Next, one more cut set I can draw here at node C, which is denoted with C3, which consists of the branch, this branch 3, and the remaining are the remaining 2 are the links. Okay, so this is third cut set. So that's all. We are unable to draw no more any more cut sets. Okay, okay, if you draw a cut set at point D, it won't be a cut set. Okay, cut set means it must consist of one and only one branch of the tree, right? um, and together with the links. If you draw the cut set here at point D, okay, it will have only branches of the tree, so it won't become a cut set. So the possible number of cut sets here only 3: C1, C2, C3. So now, before going to how to get the cut set matrix after this, so we have to write down the KCl equations with respect to each cut set. Then only we can write the matrix, cut set matrix. So how to write the KCl equations for cut set? We know that, okay, if the cut set direction orientation is same as the branch current direction, then that is taken with positive sign. Okay, if it is opposite, take with negative sign. So for that we have to take a cut set direction, cut set orientation. So that is our choice. I have chosen C1 direction, cut set C1 direction, left side. Okay, we can see with the blue color one, with blue color arrows. So this is a orientation I have taken. So now, first, okay, this is branch 1, okay, this is 2, this is 5, right? So see, if you branch 1 current is upward. Okay, it is same as the cut set orientation. So that's why KCl, it becomes in equation I1. Next, what about branch current I2? Okay, see, if you can see, I2 two direction is like this, so which is opposite to the cut set orientation, so minus I2. Next, if you see branch 5 current, it is mentioned like this. Okay, so this is opposite to the again C1 direction. Okay, we have taken C1 direction left side, so that's a minus I5. Okay, so that's all. The cut set it has only 3 branches. So equation is given by I1 minus I2 minus I5 equal to 0. Okay, now put that in matrix. Okay, here we know that in cut set matrix, the order is given by number of cut sets over number of branches. This is with respect to branches. What are those? Okay, the branches are 1, 2, 3, 4, 5, 6, right? Branches. These are the branches. So branches. So first equation, okay, C1, what is equation? I1 minus I2 minus I5. So that's why under branch 1 plus 1, under branch 2 minus 1. There is no I3 current, there is no I4 current in the first equation. So 0, 0. And this next is, we have minus I5. So minus 1 under branch 5. Next 6 under 6 also 0. Okay. So based on the equation, simply put the coefficients here. Okay. So that becomes row 1. Okay. Okay, I1 minus I2 minus I5. So only under branches 1, 2, minus 5 we have the values. Okay, remaining are zeros. Next, about the cut set 2. Cut set 2, okay. So same thing, assume the orientation for the current cut set 2. So downward I have taken, shown with blue color. So now look at the equation, write down the equation C2. So this is 2, this is 4, and this is 6. So Now, first I2. I2 direction is opposite to the C2 direction, cursor direction. So, minus I2. Next, I4. I4 direction also opposite to the C2 direction. That's a minus I4. Next, I6 direction also opposite to the C2 direction. That's why minus I6. So, minus I2, minus I4, minus I6. So, all are minus. So, I multiplied with minus. So, before putting that in matrix, so C2 for cut set C2, the coefficients, there is no I1 term, so 0. My I2, okay, under branch 2 plus 1, there is no I3, so 0, and then plus I4 plus I6, right? So plus 1, I5 0, and I6 plus 1. Okay, so this is the all these are the simply like first row, putting the coefficients here. Okay, whatever are there, just put this simply put the coefficients here. Okay, remaining values are 0. Next, cut set C3. Cut set C3, writing the KCl here. So you can see okay. Now cut set C3. So this is a direction. This is a direction I have taken. So I have taken again C3 also left side. So I3. So I3 direction is opposite to the C3. Cut set C3 direction. So minus I3. Then I5. I5 is also opposite to the C3 direction. So minus I5. Then I6. I6 is current direction is same as the C3 direction. So plus I6. So minus I3 minus I5 plus I6. Okay. So put that in matrix. So for C3 third row. So we have I3 term minus 1. Okay. And then I5 minus 1 under branch 5 minus 1 and branch 6 plus 1, right, based on the equation. Remaining values are zeros. Remaining are zeros. Okay, so this is a cut set matrix written. Next, writing the finally according to the question. According to the question, we have to determine the branch voltages, right? So using this matrix, cut set matrix. So you need to know this equation. So branch voltages VB is equal to transpose of C multiplied with tree branch voltages. Okay. So now what is VB? VB is nothing but branch voltages V1, V2, V3, V4, V5, V6. Okay. Now matrix C transpose. Okay. So what is a C matrix? Transpose of it. So 1, 0, 0, minus 1, 1, 0, 0, 0, minus 1, and 0, 1, 0, and minus 1, 0, minus 1, and 0, 1, 1. So that is a that is a C transpose. Next, tree branch voltages. So we have the tree with branches 1, 3, 4. So VT1, VT3, VT4. So tree branch voltages. So I have taken branch voltages denoted with V1, V2. Branches are 1, 2, 3, 4, 5, 6. So accordingly, its voltages means branch voltages V1, V2, V3 and so on 6. Then tree branch voltages. So we have the tree with the branches 1, 3, 4. That's why I have taken here the notation different from the branch voltage VT1, VT3, VT4. Now, so just know the order this is a 3 by 1 matrix and this is 6 by 3. Okay, so finally we can get the branch voltages. What are the branch voltages? Therefore branch voltages V1 is equal to, multiply this matrix, so VT1. Okay, then branch voltage 2 is equal to minus VT1 plus VT3. Okay, multiply the matrices, two matrices. Okay, C transpose by 3 branch voltages. Next, branch voltage V3 minus VT4. Next, V4. V4 is given by VT3. Next, V5 is given by minus VT1 minus VT4. V6 is given by VT3 plus VT4. So that is how branch voltages are determined. They are determined using the tree branch voltages. Okay. So now, next. Okay, next is finding the branch currents. Okay, next finding the branch currents using tie-set matrix. So let's problem is given. So here the problem given like this: determine the branch currents in terms of link currents using tie-set matrix with an example. So in the problem they have not given any graph. Okay, any circuit. So directly they are telling that you take an example with an example. Okay, so we have to take an example graph. From that, okay, take the selected tree, then accordingly write down the tie-set matrix. Okay, then finally determine the branch currents. Okay, branch currents. So solution, coming to the solution. So here consider, so we can see, consider the following directed graph. So this is a graph I have considered. Directly I am showing with a tree, selected tree. Actually from the previous similar problem, similar graph I have taken. Here I have denoted nodes with letters 1, 2, 3, 4. There are 4 nodes and the branches are with the alphabetical letters. So A, B, C and up so on 6. Okay, 6 branches. So here this is the graph I have taken to solve this problem. So see that here the graph is the tree is taken with the branches C, D, E. Okay, we know that what is meant by a tree. Okay, so tree means it is a connected subgraph with the same number of nodes of the original graph, but no loop in it. Okay, that's why the tree is taken with the branches C, D, E, and remaining 3 becomes the remaining 3 are the co-tree. That means the links. They are the links. So now from this, so to write down the tie-set matrix, we know how to find the tie-set matrix. Means basically we need to get the tie-sets, fundamental loops. Tie-sets means they also call it as fundamental loops, F loops. Okay, we need to find the tie-sets. Okay, then from that, based on the number of tie-sets, fundamental loops, okay, we can write the tie-set matrix. Okay, now so what is meant by a fundamental loop? In the name itself it is there. Okay, for the considered tree, if we add a link, if we add a link, there will be a loop that is called fundamental loop. So now see that first loop, okay, loop 1, name it as loop 1. So with the tree branches C, D, E. So if we consider the link F, okay, that is shown with the links are shown with dotted lines, we know. So if we add this link F, so the closed path is, so this is a closed path, right? So now to get the tie-set matrix, we need to write down the KVL equations. So that is not shown here, but I will tell. So loop 1, for first loop 1, we need to write down the KVL equation. So for that, assumed direction, this is the whatever I have drawn is the assumed direction. So write down the KVL equation in this loop, okay. So we know what is the convention for the to write the KVL equation. If the assumed direction is same as the voltage direction in the loop, okay, so then that is taken with minus, okay, otherwise otherwise plus. So assumed direction is same as the VF direction, voltage across the branch F. We are writing the KVL, okay, voltages in the loop, okay. So that's why minus VF. Then what is the next branch? E. So that is opposite. If you look at here, E opposite, VE is opposite to the assumed direction. So plus VE. Next is minus VC equal to 0. Okay, that is the first equation. Okay, so next, so put that in a tie-set matrix. We know that tie-set matrix, first row I'm writing. So V minus VF plus VE minus VC. So here they have multiplied with the minus, okay. So then they have written the coefficients here. So minus, we have minus VC, okay. If you multiply with minus, it becomes, that becomes plus, this becomes minus, then this will be plus, okay. So that's why under branch, and these are the branches, right? So under branch A, we have VC minus VE plus VF. So only under branch C, E, F, we have the coefficients. Remaining are zeros. Then loop 2. Okay, next loop 2, that is formed with the link A. Okay, so that's why this is a loop, closed path. Now writing the KVL for loop 2. So VA direction is same as the assumed current, assumed direction. So minus VA minus VD minus VC equal to 0. So all are minus, so multiply with minus, so equation all positive coefficients. Those are VA, branch A, then branch C, under branch C plus 1, under branch D also plus 1. Remaining values are zeros. Okay, then loop 3. Loop 3, okay, that is formed with the third link. We have 3 link branch B. So this is the assumed direction. So plus VB minus VE plus VD. So see that here under branch B plus 1, VD plus 1, VE minus 1. Okay. Okay, sorry, VE also plus 1. E direction is opposite to the assumed direction. Right? So that's why that one also plus only. So under D we have +1, under E also +1. So 3 loops, only 3 possible loops. So that's why the order of the die-set matrix is given by number of loops and number of branches. So that's why 3/6. So L1 loop 1, L2, L3. So the branches. So 3/6. So that is how die-set matrix is written from the loop based on the number of loops. Okay, and then finally what we want to write down the link currents. Sorry, we want to get the branch currents. So branch currents is given by dt multiplied with IL. Okay, transpose of die-set matrix multiplied with link currents. So let us write down branch currents are, what are the branches? We have denoted with IA, IB, IC, ID, IE, IF, right? Then what is the die-set matrix? We have die-set matrix, we have 0, 1, 0, 0, 0, 1 and 1, 1, 0, 0, 1, 1, minus 1, 0, 1, 1, 0, 0. That is a transpose, B transpose. And link currents we have. So the links we have, okay, based on the links, 3 links we have. So ILA, ILA, ILB, ILF. So the the links we have with the branches A, B, F. That's why the link currents become ILA, ILB, ILF. Okay. Now, so this is a matrix B transpose is a 6/3 matrix and IL is a 3/1 matrix. So the branch currents, finally branch currents IA is given by, from this matrix multiplication, ILB, IB is given by ILF, IC is given by ILA plus ILB, and ID is given by ILB plus ILF, and IE is given by minus ILA plus ILF, IF is given by ILA. So that is how finally branch currents are written. Okay, so this is a procedure finding the branch currents using die-set matrix. So that's all for now. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.